When you generate videos with AI, search for information with AI, and chat happily with digital humans, have you ever wondered what supports all of this? The three elements of artificial intelligence: data, algorithms, and computing power. Because data is very important, tech giants buy data at high prices. In 2024, ChatGPT's parent company, OpenAI, offered $250 million to purchase a 5-year copyright from News Corp, using articles from media like the Wall Street Journal, the New York Times, and the Times to train AI. Because algorithms are important, the value of top programmers is skyrocketing. $1 million annual salaries are nothing special, and even tens of millions are not news anymore. After all, there are people who have received a total compensation of over $200 million. Data and algorithms are important, but ultimately they rely on computing power. When it comes to computing power, the first thing you think of is GPUs, is graphics cards. But in reality, the most fundamental computing power is electricity. In 2025, the power consumption of data centers in China will account for 2.4% of the national electricity consumption. By 2030, it will double to 4.8%. The US is even more exaggerated, with data centers' total power consumption accounting for 4.4% of the national total in 2023. Globally, by 2030, the total power consumption of data centers will reach approximately 945 trillion kilowatt hours. What does that mean? It's roughly equivalent to Japan's current annual electricity consumption. So these tech giants are thirsty, really thirsty. In 2024, Microsoft bought all the electricity for the next 20 years from the 3 Mile Island nuclear power plant. The number 2 reactor at this nuclear power plant experienced a severe nuclear leak in 1979 and has been out of use since. In the same year, Amazon and Google also spent a lot of money buying electricity, even straightforwardly building new nuclear power plants. Let me tell you what it means to prepare the provisions before moving the troops. We know that the progress of human civilization has only changed the way we boil water. Currently, the main sources of power generation worldwide are still thermal and nuclear power. Whether it's a thermal power plant or a nuclear power plant, new construction and expansion are not easy. Project initiation, site selection, environmental assessment, design, construction, commissioning, grid connection, how can you possibly get it all done in less than 5 or 8 years? At this speed, when has the tech industry, which values efficiency and rapid outcomes, ever endured such delays? By the time your power plant is built, the AI bubble might have already burst. From the perspective of energy transfer, generating electricity by boiling water involves converting the chemical or nuclear energy of the fuel into thermal energy, then into the internal energy of water, then into the mechanical energy of a turbine, and finally into electrical energy. This entire process requires boilers to boil water, turbines to extract shaft power, condensers to condense steam, and cooling towers to dissipate heat from the condensate. Thanks to water, we can fully extract the energy from the fuel. But it's also because of water that the entire system becomes very bulky. So you might ask, is it possible not to boil water? Good question. You actually can. The turbine has a cousin called the gas turbine. The turbine operates using steam generated from boiling water. Gas turbines operate using high-temperature, high-pressure air produced by burning oil, natural gas, or pulverized coal. Looking at energy conversion, chemical energy is transformed into internal energy in the combustion chamber of a gas turbine. Internal energy is transformed into mechanical energy by the turbine behind the combustion chamber. Compared to generating electricity by boiling water, gas turbines are much more integrated, compact, and efficient. But although they're flexible, just look at the high-temperature gases they emit. What are those? That's all precious energy. So, using gas turbines alone for power generation, although fast and able to start in minutes, is inefficient. If you want to improve efficiency, you can use the high-temperature gases to heat water. That's right, back to the old method of boiling water. But overall, gas turbines rely on their speed. They've always been frequent guests at power plants. Although not the main source of power, they can quickly step in for grid peak shaving. Power-hungry data centers have also taken a liking to the speed of gas turbines. In the first quarter of 2025, new global orders for gas turbines increased by 36%. In North America, the increase was an astonishing 187%. Manufacturers of gas turbines are flooded with orders. Some factories have orders scheduled through 2028. Lathes are working so hard they're sparking, yet demand still exceeds supply. While waiting for new machines, GPUs are crying out in hunger. Is there any other way? Yes, there is. The gas turbine has a close relative called the turbofan engine. The most mainstream aircraft engines now, well, strictly speaking, it's a bit inappropriate to say gas turbines and turbofans are close relatives, because the ground turbines used in power plants and the turbofans flying in the sky both belong to gas turbines. However, now everyone calls them this way. When you say gas turbine, you know it's on the ground. When you say turbofan, you know it's in the sky. The core three components of gas turbines and turbofans are both compressors, combustion chambers, and turbines. The working principle is exactly the same, both following the Brayton cycle. The compressor draws in and compresses air, then fuel is sprayed and burned in the combustion chamber. Finally, high-temperature, high-pressure gas drives the turbine to output shaft power. So it wasn't long before the tech giants in gas turbines set their sights elsewhere. They turned their attention to aircraft engines, sparking the conversion of aviation engines to gas turbine business. In the wave of artificial intelligence, the aviation industry, as a traditional sector, was originally just a bystander. They are just onlookers, and ended up becoming victims without realizing it. So, for viewers with planes at home, you must be cautious, try to fly less lately, and if you can bike, don't fly. Because if your engine breaks down, you might not be able to buy replacement parts. Let's say gas turbines and aircraft engines are like brothers. Although their working principles are identical, there are many differences. For example, in terms of energy output, we want the shaft power from a gas turbine to drive a generator for electricity, not for thrust. But for aircraft engines, it's the opposite. They primarily output thrust. Another example is fuel. Aircraft engines burn aviation kerosene, which is truly premium-grade refined fuel. But gas turbines don't have these conditions. Kerosene, diesel, natural gas, even coal dust can all burn. And the working environment, aircraft engines have such a clean surrounding, whether on the ground or in the sky, something gas turbines can only envy. Around gas turbines, dust flies everywhere. Hearing this, you might think, hey Mr. Ma, listening to you, I feel like dismantling the aircraft engine at home, converting it to a gas turbine, and selling it might make money. Just tell me, if I modify it, what do I need to change? First, you need to remove the tail nozzle, because there's no need to accelerate the exhaust gas anymore. Second, you need to remove the large fan and outer duct at the front, because they are no longer needed for thrust generation. Third, you should add another turbine to extract as much as possible from the high-temperature gas to reduce waste. Fourth, you need to modify the combustion chamber and nozzle, eliminating its picky habits. It shouldn't just burn aviation kerosene. You might even need to consider adding a faucet to the combustion chamber to spray water for cooling to prevent nitrogen oxides formation. Otherwise, the Environmental Bureau will come scolding. Fifth, you need to add a filter in front of the compressor to prevent dirt from being sucked in and damaging the blades. Also, you need to replace this filter regularly, or it will get clogged. Actually, even after filtering, fine dust will still get sucked in and stick to the compressor blades, damaging the aerodynamics meticulously designed by engineers working overtime. Then the next question arises, how often should I replace this filter? How often should I clean the compressor? Great question. Originally, these two cycles were decided based on experience, just an approximate time. But experience can be inaccurate. If done too early, it's wasteful. If too late, it delays power generation. Now, it's the era of artificial intelligence. You can't rely entirely on experience anymore. For example, Tianfu Software's self-developed industrial AI platform. It can use machine learning algorithms to intelligently determine the working state of equipment and determine the optimal maintenance cycle. Specifically for the gas turbine filter, first collect parameters such as pressure loss, compressor flow, inlet temperature, and outlet pressure. Then use these for machine learning to obtain a data model. This data model can be used to determine if the filter is clogged and when it should be replaced. Using this data-driven intelligent maintenance, Tianfu just helped a domestic power plant save over 9 million yuan in costs. And speaking of compressor cleaning, using parameters like compressor inlet pressure, inlet temperature, flow, and speed for machine learning, the obtained data model can also intelligently determine if the compressor is too dusty and when it needs cleaning, greatly saving costs. Tianfu Software's industrial AI platform has a low entry threshold. Even if you're not in IT, just an ordinary engineer, you can set up such an impressive monitoring screen. You could say it's both useful and visually appealing. If you happen to have a gas turbine at home and are developing a power plant, you should definitely try it. We say artificial intelligence relies on electricity, and artificial intelligence can also serve electricity. Companies like Tianfu, deeply rooted in industrial software, have also been using their industrial AI to ensure the electricity safety of the whole society.